All right, we are on day 4 of our review for the AP test. We are now on to Unit 7. If we look at College Board's questions about what Unit 7 should be, it says, identify the question to be answered or problem, should I worry, to be solved. So we're looking at error or constructing confidence intervals for a population, verify inferential procedures apply in a given situation, and then what topics we quite haven't addressed in our review questions would be a chi-squared test and error analysis. So if we're thinking about type 1 and type 2 errors. So if you want to see all of the different types of standards that College Board thinks for Unit 7, feel free to look at the Schoology class page. I have pulled up the first of 2 questions. So without further ado, let's just get right into it. So question 1 from Unit 7 says, a bank categorizes its customers into one of 3 groups based on their banking habits. A random sample of 30 customers from each group was selected, and the number of times each customer visited the bank during the past year was recorded. The following table shows the summary statistics. So Group A, Group B, Group C, 30, 30, 30. We have our X bar, so our average number of visits, and our standard deviation. The bank manager will investigate whether there is a significant difference in mean numbers of bank visits for the groups. Multiple 2-sample t-tests will be conducted, each at a significance level of an alpha of 0.05. How many t-tests will need to be conducted for the manager's investigation? List the pairs of groups for each test. So this question, if we want to just get a little detailed oriented, is how would you pair up these groups? And it's not something that order matters. So let's say 1A. If you had a t-test comparing A and B, that's 1. If I had a test comparing A and C, that's 2. And then the last one would be B and C. If I'm comparing the difference of A and B, that should be the same thing as comparing B and A. So there will be 3 t-tests conducted. So that one, it's not really asking a whole lot from us. Let's keep reading. The significance level of a single hypothesis test is the probability of making a type 1 error. The manager knows the manager wants to know the probability of making a type 1 error for multiple t-tests, not just for a single t-test. The probability is called the family error for type 1 error, which is also known as the family error rate. B, a t-test has 2 possible outcomes: reject or fail to reject the null hypothesis. Suppose the null hypothesis is true. If the null is rejected, the result is statistically significant, which would be a type 1 error. If the null hypothesis is not rejected, the result is not statistically significant, which would not be a type 1 error. Let S represent a statistically significant result, and let N represent a not statistically significant result. So in part 1, if the probability you get a statistically significant result is 0.05, what is the value of not statistically significant? Well, P of N is just 1 minus the statistically significant probability, which is what we would expect, 1 minus 0.05, which is 95 or 0.95. Part 2 then goes, the family error rate is the probability of obtaining a significant result for at least one of the t-tests conducted under the assumption that the null hypothesis is true. Use the tree diagram to determine the family error rate for 2 t-tests, each conducted at a level of 0.05. So what we are looking for is what's the probability of at least 1 S. Or what we really want to know is at least 1 is saying 1 minus none. So I want to know 1 minus the probability of none and none. So if we're just looking to fill this in, I know the probability of S is 0.0, let's write this in, 0.05, and this is 0.95. And again, if we did it the second time, it would be 0.95, 0.05, 0.95, 0.05. And so what we are looking for is 0.95, 0.95, and then we'll do 1 minus that. Hopefully that made sense. So back on my notes, I have 1 minus 0.95 squared, which my calculator has told me that is 0.9025. Sorry, 0.95 is, this would be 1 minus that, which gives me the family error rate is 0.0975. Now, that's not the only way to do that problem. We could also think of, instead of just n and n and doing the complement, you could also do at least one. So I need one s in some capacity. So that would be, let's do this in red, these two, or, which means plus, these two, or these two. And I would much rather just do one calculation than 3. So that's why I would think of it in terms of the complement, which is, again, when we dealt with probabilities, when you see that word at least one, it's much better to think in terms of the complement than anything. Okay, that takes care of part 2. C, determine the family error rate of the number of t-tests identified in part A, each conducted at a level of alpha 0.05. Okay, so what is this asking you is saying in part A, we saw that there were 3 tests. So from part A, let's identify this. This is C, right? From part A, our 3 tests were AB, BC, and AC. If we're thinking in terms of the error rate, the probability of no significant result, so the probability of no significant result would be the probability of n and n and n, which is 0.95 3 times. So the family error rate would be 1 minus 0.95 to the 3rd. Well, if I just type that into my calculator, I will get 0.142625, or approximately 14%. And you can see how these questions are starting to build on one another so that we see what's going on. If you wanted to, you could also build a tree diagram, just like you had in part B. So the first one would be S or N, and then the next one would be S or N, and then the next one would be S or N, S or N, and we'll do the same, S, N, S, N, S, N. And each one of those, you can see, if I want to find the error rate, that's saying some success rate. So it's far easier to just calculate n and n and n and do 1 minus that. Last part, part D. The manager wants the family error rate to be close to 0.05. Suggest a significance level for alpha that would be used for all the values of the individual t-tests that will bring the family error rate close to 0.05. Okay, so what we saw in this case was that our error rate at a 0.05 level was about 14%. So I want that to be lower. So obviously, I want a lower alpha level. So for, let's say, for part D, reduce alpha to reduce error rate. Now, if I want it to be close to 0.05, and there are 3 tests, we might try just taking alpha and dividing it by 3. Or 0.05, which is what we started with. If we cut it into 3, we can check what this is going to be. So in this case, that would mean the probability of success is 0.017. And that means probability of, let's get that to look right. Probability of not significant would be 0.983, if I can do my math correctly. So again, we could do the exact same calculation to find the error rate. So error rate would be 1 minus probability of n and n and n. So that would be 1 minus 0.983 cubed, which turns out to be roughly 0.94986, which means that the family error rate would be approximately 0.05014. Now again, is that the only way? No. So let me show you a slightly different way. If you knew that the error rate was the probability of not significant cubed, and we want to say that's equal to 0.05, we could just straight up do that math. So to do this, I'm just going to switch spots. So 1 minus 0.05 equals probability of n cubed, or 0.95 equals probability of n cubed, or the cubed root of 0.95 is equal to probability of n for not significant. So that would give us approximately 98.98305. I type that into my calculator, which means that what I'm asking for is the probability of success, because that will be our alpha level, that would be our significant level, is 1 minus 0.98305, which turns out to be 0.04999. Sorry. Slow down, Mr. Swenson. If I do that, I get, 0.01695. So either way, you can see we get roughly the same thing. And again, this is pushing us into new territory, which the AP loves to do, especially for question 6, that takes something that we know and then extends our knowledge, or something that is brand new for us. So that takes care of question 1. If I pull up question 2, let's see what we get. So as we get set up, the following STEM plot shows the swimming speeds in kilometers per hour for a random sample of 31 emperor penguins. Interesting. And we got a stem and leaf plot. Great. A. Oh. Poor Mr. Swenson. Can't pull up the right note. A. The mean of the sample is 9.771 kilometers per hour, and a standard deviation is 0.944 kilometers per hour. Construct and interpret a 95% confidence interval for the mean swimming speed of all emperor penguins. So a couple of key things for, let's say, this bigger. 2a. For a confidence interval for means, we need n. N was 31, which will help us find the degrees of freedom, which is going to be n minus 1, which is 30. That will help us find our critical value. So I always start with the 95% confidence interval. When we are doing this, many of you are going to want to jump straight into the answer, but make sure that you panic first. And so when you are building a confidence interval, it's not good enough to just write out what the numbers are. You need to justify how you can build this interval. So first off, the parameter of interest is the true velocity of swimming speed, the true mean of emperor penguin swimming speeds. So that's my parameter of interest, my assumptions and conditions. So we have to think back. What are the things that we need in order to have a mean? And here, randomly selected, usually. And then we have to look at our sample size here is equal to 31, which is large enough to assume that the sampling distribution is approximately normal, or large enough by the central limit theorem to justify using a normal model. So once we get to that, now we build our confidence interval. Let's see where I'm at here. So we would have x bar plus or minus the critical value of 30 degrees of freedom times our standard deviation of our sample over the square root of n. And I encourage you to write this out. Now, to find this critical value, you could go inverse t, or you can look at the formula sheet. We're looking for 30 and for a 95% confidence interval. So the correct critical value is 2.042. If we want to see how we get that, let's just jump straight to our calculator one more time. Just as a reminder, let's pull up a calculator. If I want to find critical values, I need to go to distributions, and we are going to go inverse t. I want a 95% confidence interval, so I go 0.975 because it's a one-tailed test, and I have 30 degrees of freedom, and I get 2.042. All right, let's switch back to my iPad. Let's actually see what we are writing. There it is. So then we just go x bar we were given is 9.771 plus or minus 2.042 times our standard deviation was 0.944 over square root of 31. And once you type that in, you will get 9.771 plus or minus 0.346, which gives us an interval of 9.425 to 10.117. Now that's not good enough because it says construct and interpret. So we need to interpret this. We are 95% confident that the true proportion, not proportion, true average, let's put this in context, average swim velocity for emperor penguins is between 9.425 kilometers per hour and 10.117 kilometers per hour. There we go.
Mr. Swenson,
Yes, sir.
that's a T interval, right?
That is a T interval. I probably should have named that. So this is a one sample T interval. Because it is, we're dealing with quantitative data here. So absolutely, when we're writing out panic, parameter, assumptions, and conditions, name the interval, write out the interval, and then your conclusion. Thank you for catching me on that. Always worthwhile justifying what you are doing. So part B says, can the estimate of the mean swimming speed be generalized to all types of penguins and explain? So I want you to think about this. Would it be reasonable if we just took emperor penguins and then saying it for all types of penguins? Well, we didn't have all types of penguins in these speed measurements. We were specific to just this type. And so I don't know if you know any different types of penguins, macaroni penguin. They come in various sizes. And so if we're only measuring one group, then we can only justify to this group. So per part B, it is not reasonable to generalize to all penguins. And we need a justification. So because the sample that we had only consisted of emperor penguins. And that takes care of all of the review questions. Now that doesn't mean that there are, you wouldn't have to do inferential statistics for a linear regression, or we couldn't have a chi-squared test, or the difference in means. These are just a sampling of questions that you would be expected to answer. So hopefully over these past couple days in these videos, it goes through how you should answer these questions in full detail.